Welcome. In this video, we're going to look at negative and zero exponents. And remember, with all of these, we're trying to look at why these things work so that we're not just memorizing some rule, but our rules can help us be a little bit more efficient once we understand why they work. So we're actually going to slide down to this blank space here for a minute to take a look at some patterns with exponents. So we're going to take a look first at, let's just pick a base here. So I'm going to do 3. And I'm going to look at 3 with some exponents. Okay, and then see what we get. So if I take 3 to the second power, really that means we have 2 factors of 3, which is 9. 3 to the third power means I have 3 factors of 3, which is 27. 3 to the fourth power, 4 factors of 3, which is 81, right? And I could keep going. So if we look at some patterns here, excuse me, as we increase our exponent by 1, what we're really doing each time here is multiplying by another 3. So if I'm moving down my table here, I'm multiplying by another 3 each time we move down the table. So what I'm going to see is what happens as we move backwards. So if I'm multiplying by 3 each time we go this way, if I move backwards along my table, if I go this way, we're going to divide by 3 each time. So if we take 9 divided by 3, I get 3 to the first power is just 1 factor of 3, which is 3. And if we divide by 3 again, 3 divided by 3 is 1. 3 to the 0 power is 1. This will happen with any power or any base, right? If I had 2 to the first, that's 2. 2 divided by 2 is 1. So 2 to the 0 is 1. K to the first is k. K divided by k is 1. So anything to the 0 exponent, any non-zero number raised to the 0 exponent is 1. So no matter what your base is, if you take it to the 0 exponent, it's 1. Negative 3 to the 0 power is 1. Ooh, this one's a little tricky. Be careful here. What does this really mean? This really means negative 1 times 7 to the 0 power. So we're going to do our exponent first. 7 to the 0 power is 1. 1 times negative 1 is negative 1. Okay, 3/4 to the 0 power. Again, I don't care what the base is. Anything to the 0 power is 1. M to the 0 power is 1, as long as m is not 0, right? So anything to the 0 power, any non-zero base raised to the 0 power is 1. Okay, let's take a look now at some negative exponents. I'm actually going to come back here to my table here and continue on. This is my table there. So if I take 3, if I continue my pattern here, if I'm going to the negative 1, 3 to the negative 2, 3 to the negative 3, etc. Okay, so if I'm going backwards again, we're going to divide by 3. So 1 divided by 3 is 1 divided by 3. 1/3 divided by 3 is the same thing as multiplying by 1/3. So this is 1 over 3 times 3, or 1 over 3 to the second, which is 1 over 9. Okay, 3 to the negative third is 1 over 3 times 3 times 3, or 1 over 3 to the third, or 1/27. So that negative exponent is going to take my repeated multiplication and make it repeated division. So I'm dividing by 3 over and over and over again. So a to the negative n is the reciprocal of a to the n. So what that means is that if I have a to the negative n, that's equal to 1 over a to the n. Similarly, if I have 1 over a to the negative n, now this is division. If you divide, you end up multiplying, so that's a to the n. So anytime you have a negative exponent, it changes division into multiplication, multiplication into division, and we're just looking at those inverse operations there. So if I have 4 to the negative third, that's the same as 1 over 4 to the third. I'm dividing repeatedly. So that's the same as 1 over 4 times 4 times 4. 4 times 4 is, this is 1 over 64. Okay, negative 16 to the negative 1 is the same as 1 over negative 16 to the 1, which is the same as 1 over negative 16. Okay, negative 5, okay, careful here. This negative is not part of my base. Put in a negative 1 times if that helps you. So this is negative 1 over 5 to the second, or negative 1 over 25. Difference here, this negative here, since it's in these parentheses, those parentheses are saying take this with you when you raise it to the exponent, versus here that negative's not. So this is a negative 1 times 5 raised to the power. Powers are more powerful, so we're going to do powers before multiplication. Ooh, 0 to the negative 5. 0 to anything. If you take 0 times anything, 0 times itself, however many times, it's always 0. Doesn't matter what our exponent is. Okay, negative 5 to the negative 2. Okay, so this is very similar to this one here, but the negative we're bringing with us. So this is the same thing as 1 over negative 5 squared, which is the same as 1 over negative 5 times itself. Negative times a negative is a positive, so this is 1 over 25. Okay, so be careful with those negative exponents and looking at where they go. Let's do a little bit of practice with this together. Okay, so we want our simplified answer to have only positive exponents. So if I have a negative exponent, that means I'm not done. I can go further. So 2 to the negative fourth, remember this negative turns my repeated addition, multiplication into repeated division. So this is 1 over 2 to the fourth, which means it's 1 over 2 times 2 times 2 times 2, which means it's 1 over 16. Okay, 7w to the negative 3. Make sure that you remember that this is multiplication. It's not 7w to the negative 3. The 7 is times w to the negative 3. So that means the 7 is going to stay in the numerator. The w is going to move to division with a positive 3. Okay, multiplication does not tie things together. G to the fourth over h to the negative 6. So this has a negative exponent, so we're dividing, undo dividing, we multiply. So this becomes g to the fourth, h to the positive 6. Okay, you could put that over 1, but we don't need the 1 in the denominator like we do in the numerator. R to the negative 3, okay, so this thing has to become division, so we're going to put it in the bottom of our denominator. That's just what I was talking about. We do need that 1 up there. 7r to the 3, right? The 7 doesn't have a negative exponent, so it's going to stay right where it's at. Okay, let's look at what these things are. I'm going to put some multiplication in here so I can remember that those things are being multiplied. So this 2 has a negative 3 exponent, so that means that that is going to go in the denominator. I'll deal with that third power in a second. This is x to the 1, so it's just going to stay there. Y to the second, so it's just going to stay there. Ooh, z to the 0, anything to the 0 is 1, so I could write times 1, but anything times 1 is just itself, so I don't necessarily need that 1 there. Okay, a little more work to do here. 2 to the third is 2 times 2 times 2, so we have xy squared over 8. Okay, negative 5, not a negative exponent. That's going to stay right there. That's just a negative number, negative 5. K to the negative 2, that does have a negative exponent, so we're going to move that up to the numerator to make it positive, k to the positive 2. Okay, lots going on this last time, so let's take it one at a time. A to the 0, this is 1. So we are just going to get rid of that a to 0. It becomes a factor of 1. I could write times 1 if I need to. B to the negative 2, that's going to move to the denominator. C to the negative 3 is going to move to the numerator. And this d to the 6 is going to stay right where it's at. So we have c to the third in the numerator now, b to the second in the denominator now, and that d to the sixth also in the denominator. A to 0 is 1. So that factor that is essentially gone because we can write times 1, but we do not have to. Hey, that is all we have for today, looking at some negatives and zero exponents. Thank you so much for watching.